students. By this time we know how to add two matrices, subtract them, or multiply two matrices, and we also know under which conditions is this addition, subtraction, or matrix multiplication possible. We have also studied properties of addition of matrices and various properties of multiplication of matrices. Now, knowing all these concepts, we'll try out some questions from exercise 3.2. This exercise has got some very easy questions, so I'll pick up the different kinds of questions. So I'm going to start here with question number 6. Question 6 is to simplify cos theta multiplied by this matrix added to sin theta into this matrix. So in this question, first of all, we are going to use the concept of scalar multiplication, which means each element of the matrix is to be multiplied by cos theta. So elements are now cos square theta, sin theta into cos theta, minus sin theta into cos theta, and cos square theta. Here also we are using the concept of scalar multiplication. So sin theta is multiplied to each element of the matrix, and the new matrix has elements sin square theta minus cos theta sin theta, sin theta cos theta, and sin square theta. This is a 2 by 2 matrix and a 2 by 2 matrix. So matrix addition is easily possible. Adding corresponding elements, cos square plus sin square theta, sin theta cos theta minus this will cancel out to give 0. Likewise, minus sin theta cos theta plus sin theta cos theta will give 0, and cos square theta in plus sin square theta is this, and we know from trigonometry that cos square theta plus sin square theta is 1, and hence the result simplifies to an identity matrix of order 2. The next question we are doing is question number 7, second part. Find out values of x and y. So find values of x and y when this condition is given. So let's call this as equation number 1. This is equation number 2. Now here x and y are matrices. These are not variables. There is a matrix on the right side of the equation, so we know it's a matrix equation. So x and y are matrices of the same order. That means order of matrix x is 2 by 2 and the order of matrix y is also 2. To solve these equations, let us multiply equation 1 by a constant 3 and equation 2 by a constant 2. The idea is to eliminate the matrix x. So on multiplying by 3, the left hand side of the equation is this, and on the right side this matrix is to be multiplied by 3, means each element of the matrix is to be multiplied by 3. The second equation also is to be multiplied by 2. On the right side, each element of the matrix is multiplied by 2. And these equations now can be subtracted. On subtracting, the signs here will change. So this term gets cancelled. 9y minus 4y is 5y. On the right side it is matrix subtraction. So 6 minus 4, writing the result directly. 10 minus of minus 4 is 13. 12 minus of minus 2 is 14. 0 minus 10 is this. And therefore the matrix Y has been obtained as 1 by 5 times this matrix. This is again scalar multiplication. So matrix Y can be written as a matrix with elements 2 by 5, 13 by 5, 14 by 5 and minus 10 by 5, which is minus 2. So this way we have obtained matrix Y. We have got here two equations. In any one equation we can substitute the value of matrix Y and find out matrix X. So suppose we are using the first equation. So 2 times matrix X plus 3 times matrix Y is equal to the matrix on the right hand side. So 2x plus, performing this scalar multiplication, 6 by 5, 39 by 5, 42 by 5 minus 6 equal to the right hand side matrix. Transposing the left hand side matrix to the right hand side gives us this expression. Performing this subtraction, 2 minus 6 by 5, 4 minus 42 by 5, 3 minus 39 by 5, 0 minus 6. We obtain this is 10 minus 6, 4 by 5. This is 20 minus this, so minus 22 by 5. This element is 6. 15 subtracted, so minus 24 by 5. That is value of 2x, and hence matrix X will be half of this matrix. Performing this scalar multiplication, we get, multiplying each element of the matrix by half, we get 2 by 5, minus 12 by 5, minus 11 by 5, minus 3. So this is how we have found out matrix X and matrix Y, which are matrices of order 2 by 2. So next I am going to take up your question number 12. In the 12th question, some condition is given. 3 times a matrix with elements X, Y, Z, W is equal to another matrix with elements X, 6, minus 1, 2W plus matrix with elements 4, Z plus W, X plus Y and 3. This is the given matrix equation. We have to find out here values of X, Y, Z and W. So here, performing this scalar multiplication, 3x, 3y, 3z, 3w. On the right side, adding the two matrices, adding corresponding elements, we get z plus w minus 1. This is 6 plus x plus y, 2w plus 3. The two matrices have the same order. The matrices are equal, so equating the corresponding elements. 3z is z plus w minus 1. 3y is equal to 6 plus x plus y. 3w is 2w plus 3. So from the first equation, if we simplify, we get 2x equal to 4, which means x is equal to 2. So one value we have found. From this equation, on simplification, we get w is equal to 3. So x and w we have found. Let us substitute value of w in this equation. So transposing z terms, we get 2z, w is 3 minus 1. So we get 2z equal to 2. Finally, z is equal to 1. In this equation, we can substitute x is equal to 2. Transposing y terms, 2y is 6 plus 2, which gives 2y equal to 8, and hence y is equal to 4. So in this question, we have used number of concepts. First, we have used here scalar multiplication, addition of two matrices, then equality of matrices. If two matrices are equal, the corresponding elements are equal, we obtain four equations. Solving these equations, we are able to find out values of x, y, z and w. So next we'll take up here question number 13. In the 13th question, a function of x is defined as a matrix with elements and we have to show that fx multiplied by fy gives f of x plus y. So going by the notation here, since the fx is a matrix written this way, starting with the left hand side, fx multiplied by fy is product of a matrix with variable x with a matrix having variable y. So this is how the matrix Fy is obtained. Now since both matrices are of the same order 3 by 3, so the product matrix will also be a matrix of order 3 by 3. So let's start multiplication. The first row elements multiplied by the first column, corresponding elements give us cos x, cos y minus sin x, sin y plus 0. Then first row element multiplied by second column. So it is minus cos x, sin y minus sin x, cos y plus 0. The first row multiplied by the last column gives 0. Second row multiplied by first column, sin x cos y plus cos x sin y plus 0. And the second element here is minus sin x sin y plus cos x cos y, and this row multiplied by third column gives 0. The third row multiplied by this gives 0. Third row multiplied by this gives 0, and with this multiplication we get element 1. So this is how we have obtained a 3 by 3 matrix. Now if we remember here the identities of trigonometry, we can easily find out this result. So here it is cos x cos y minus sin x sin y, which can be written as cos x plus y. That's a formula for the cost ratio of compound angle x plus y. This is a formula for sine x plus y. The third element is 0. Over here, if we take minus sign common, then this is formula for minus sine x plus y. Sine x plus y is sine x cos y plus cos x sine y. Over here, if we take this as the first term, cos x cos y minus sine x sine y, this is identity for cos x plus y, 0. Here are the elements 0, 0, 1. Comparing this with the given matrix, we know this matrix can be represented by f of x plus y, which is equal to the right hand side. So we started with the left hand side where we found out the product of the two matrices. Upon simplification using trigonometric identities, we obtain a matrix f of x plus y, which is the right hand side. Therefore, we have shown that the left hand side is equal to the right hand side. So next we try question number 15. So in the 15th question, we have to find out a square minus 5a plus 6i, where a is a matrix, I is an identity matrix, and the matrix A is defined as a matrix 3 by 3 matrix with elements this. So here A square is a matrix, A is a matrix, I is identity matrix of order 3. So when we perform this operation, we will get a matrix only. So on the right side, we will obtain a 3 by 3 matrix. So starting from the left hand side, A square. That means A into A. Minus 5 times matrix A. Plus 6 times identity matrix of the same order. So this product will give us a 3 by 3 matrix. So let's perform here. The first row multiplied by this, so this gives us 4 plus 1, 5. This multiplied by the second row, 0, 0, minus 1, 2, 0, 0. Then multiply the second row with the first column, so 4 plus 2, 5 plus 3, 8. First row, second row multiplied by second column, so 0, 1, minus 3, minus 2. And this multiplied by this, 2 plus 3 plus 0, 5. Next, 2 minus 2 plus 0. Here is 0, minus 1, 0. Then it is 1 minus 3, that's minus 2. So the product matrix. Next is scalar multiplication, multiplying each element of the matrix by 5. Here again, performing scalar multiplication. All matrices are 3 by 3 matrices, so addition and subtraction is possible. We can do it in one step. So taking the first elements here, so it is 5 minus 10 plus 6. Next 8 minus 10 plus 0. 0 minus 5 plus 0. Next element minus 1 minus 0 plus 0. Minus 2 minus 5 plus 6. Minus 1 plus 5 plus 0. Then 2 minus 5 plus 0. 5 minus 15 plus 0. Minus 2 minus 0 plus 6. And on simplification, we obtain the final result which is 1 minus 2 minus 5. This is minus 1 minus 1, 4 minus 3 minus 10, 4. So multiplying a matrix with itself, performing scalar multiplications, adding and subtracting matrices of same order, we obtain this as the resultant. This is suppose given by matrix X. So here we have got matrix X. Okay, next I'm going to take up question number 18. So in the 18th question, a square matrix A is given. I is identity matrix of order 2, and we have to show that identity matrix plus matrix A is I minus A times this matrix. So let's start from the left hand side, I plus A. Left hand side, I plus A. So identity matrix of same order plus matrix A gives us a matrix with elements 1 minus tan alpha by 2, tan alpha by 2, 1. Right hand side is I minus A into this matrix so because I and A matrices are already written here, so I'll directly subtract and write down. This is I minus A is 1 tan alpha by 2 minus tan alpha by 2, 1, which is to be multiplied by the given matrix. Now performing this multiplication, first row multiplied by first column elements gives us cos alpha plus tan alpha by 2 into sin alpha. First row multiplied by second column, so minus sin alpha plus tan alpha by 2 cos alpha. Second row multiplied by first column, minus tan alpha by 2 cos alpha plus sin alpha, and the last element would be tan alpha by 2 sin alpha plus cos alpha. So here I am going to represent it as the first element is A11. You can see here that the first element is same as this element, right? And this element and the element present here have opposite signs. This is what we have to notice. Okay, so the same matrix can also be written as A11, A12. This has got opposite sign of A12 and this is same as A11. So basically we need to find out only two elements, A11 and A12. So let's find out here A11. The element here is cos alpha plus tan alpha by 2 into sin alpha. One of the ways of simplifying the expression is to write down the tan ratio in terms of sin and cos and take LCM, cos alpha by 2. So this is cos alpha into cos alpha by 2 plus sin alpha by 2 into sin alpha. Denominator is cos alpha by 2. In the numerator, it is cos A cos B plus sin A sin B. So that is equal to cos A minus B. The identity that we have used here is cos A minus B, which is equal to cos A cos B plus sin A sin B. So this becomes cos alpha by 2 upon cos alpha by 2, which is equal to 1. So we know A11 is 1. Here the diagonal elements we have found is 1. Next we move on to find out A12. The element A12 is minus sin alpha plus tan alpha by 2 cos alpha. Here again, writing tan alpha by 2 as sin alpha by 2 upon cos alpha by 2 into cos alpha, and taking LCM cos alpha by 2, we obtain this expression. So considering the positive term first, this is like sin A cos B minus cos B sin A. So it can be written as, the identity that we are going to use here is sin A minus B, which is sin A cos B minus cos A sin B. So taking the positive term first, sin A, value of A is alpha by 2 and B is alpha, cos alpha by 2, which is equal to sine of minus alpha by 2 upon cos alpha by 2. Again using property of sine trigonometric result, this is minus sine alpha by 2 upon minus cos alpha by 2, and the final result is minus tan alpha by 2. So we have got here the element A12. So finally we can compare here. The left hand side matrix is this and the right hand side matrix. Now since we have found elements A11 and A12, we have seen earlier that the right hand side on simplification was a matrix given by these elements. So if we substitute the elements here, A11 is 1 diagonal elements. This element A12 we have found is minus tan alpha by 2. This is negative of that element, so it is tan alpha by 2. And on comparison, we can see left hand side is equal to the right hand side. The next question we take up is the 19th question. This is the last question of the exercise. It's a word problem, and how we solve a word problem using the concept of matrices is what we'll try to understand in this question. So 19th question. A trust fund has rupees 30,000 that must be invested in 2 different types of bonds. So the money for investment is rupees 30,000. The money is to be invested in 2 different kinds of bonds. The first bond pays 5% interest per year. Interest from bond 1 is 5% per annum, and the interest from bond 2 is 7% per annum. So using matrix multiplication, determine how to divide 30,000 among the two types of bonds if the trust must obtain an annual total interest of rupees 1800. So the total interest is given. Rupees 1800. The question clearly mentions use matrix multiplication. Let us as of now not use matrix multiplication and see without matrix multiplication how can we solve the question. The question is a simple one. The money for investment is rupees 30,000. So let us suppose that the money invested in first bond is rupees X, and that invested in bond 2 is rupees 30,000 minus X. So if we are not using matrix multiplication, then it means that the first bond will give an interest of 5% per annum on the amount invested in bond 1. So the interest that the first bond will give is 5% of X. The interest that the second bond will give is 7% of 30,000 minus X. If we add the two interests, we get the total interest, which is equal to 1800 rupees. So a simple equation is obtained. We can solve this equation and find out X, the money that is invested in bond 1, and likewise we can find out the money that has to be invested in bond 2. Now in this equation, you can very clearly see what we are doing is we are multiplying the interest with the amount invested in each bond. This is the concept we have to get using matrix multiplication. So now let's see how do we incorporate matrix multiplication in this question. So one thing is sure, we are multiplying two matrices. A matrix that has interest and the matrix that has the amount which is invested, and this should give us another matrix which gives us the total interest. This is a rough format of the question. How should we write it down? One of the ways is to write down the interest as a column matrix and the amount invested in each bond as a row matrix, this way. If we do the multiplication this way, then let us just check. The order of this matrix is 2 by 1, 2 rows and 1 column. The order of this matrix is 1 by 2. Since number of columns and number of rows are equal, matrix multiplication is definitely possible, and the resultant matrix will be a matrix of order 2 by 2. 2 by 2 matrix means there are 4 elements here. But the question says that the total interest is exactly one value, which is 1800 rupees. So this kind of matrix multiplication is basically not possible. Multiplication is possible, but it does not satisfy the given condition in the question. So what is the other possibility? Let us interchange. Let us make this a row matrix and this a column matrix. So if the first one is a row matrix and the second matrix is a column matrix, let's once again check. This is a matrix of order 1 by 2. This is a matrix of order 2 by 1. Number of columns and number of rows are same, so matrix multiplication is possible, and the product matrix will be a matrix of order 1. So this suits our situation because we have only one element in this matrix. So that means out of the two possibilities, this is the one which satisfies the condition given in the question, so we go ahead with this. Multiplication is possible, so what we get here is 5% into x plus 7% into 30,000 minus x should give us 1800. I've done here two steps together. I've multiplied the elements of the matrix, and then the equality of matrices, matrix concept is also used here. Simplifying the equation further, we get here 5x plus 21 in 4 zeros minus 7x is this into 2 zeros. So simplifying further, minus 2x is minus 30,000. So x is 15,000. That means the amount to be invested in first bond is rupees 15,000, and the amount that is deposited in the second bond is rupees 30,000 minus x. So amount to be invested in bond 2 is also rupees 15,000. What is important in this question is that the question said use matrix multiplication. So if we use this step here, this step shows that we are multiplying two matrices to obtain the resultant matrix. So this step is to be shown. If this step is not shown and we simply solve it using basic algebra, then we may not be able to score full marks in the question. If you want, you can also show this step. You can explain that this multiplication gives us a matrix of order 2 by 2, which is not required according to the given data. So this situation is ruled out. So in the next class, we are going to study some more important facts of matrices.